Testing, testing. I think this works. Okay, my name is Alan Ahn. I'm Director of Programs and Communications at the Global America Business Institute. Thank you for listening to this podcast series on energy, nuclear energy, hosted by Gabby. I have the privilege of speaking with Professor Jong Il Yun. He is a professor of Department of Nuclear and Quantum Engineering at the Korea Advanced Institute of Science and Technology, KAIST. We're very fortunate to have his time today. Dr. Yun, thank you for joining us. You've been a professor at KAIST for many years, which is the premier science, technology, engineering institution, higher institution of learning in the Republic of Korea. You're an expert in a broad range of areas, nuclear safety, spent fuel management. What research areas have you most recently been focusing on and has taken most of your attention?
Yes. First of all, thank you very much, Mr. An, for the kind introduction. So over the past 20 years, I have focused on the safety of spent nuclear fuel, including high-level waste. This is one of the remaining problems in nuclear industry. So we have to solve for the sustainable use of nuclear power. So in this regard, my research focuses on the reduction of high-level waste by pyrochemical process and the long-term disposal safety of deep geologic repository. So this is a little bit long history. And when I entered the Seoul National University in 1986, in which the Chernobyl accident occurred.
Okay.
I studied nuclear engineering as major at SNU and graduated in 1990. And then I moved to Germany and changed my major to mechanical engineering at the Technical Aachen. And since then, I changed my major from nuclear to mechanical engineering. And during my PhD course, I changed again. So my major, from mechanical to radiochemistry, and the radiochemistry, including actinide, related to the nuclear waste disposal. So since then, as I mentioned, I focus on the safety issues of used nuclear fuel and high-level radioactive waste. And in addition to nuclear waste disposals, I have successfully expanded my research activity to pyroelectrochemistry of used fuel in high-temperature molten salts.
You talked about your work on spent nuclear fuel management and specifically on pyro processing, and a lot of the work that you've done recently seems to focus around that. When you look at spent fuel management issues, it seems like many of the thornier issues seems to be issues of policy and social and public acceptance. Right. What do some of these technical tools, such as pyroprocessing, how do they facilitate the management of radioactive waste management, siting repositories and storage facilities?
And as you know, deep geologic disposal is regarded as one of the most suitable methods for the long-term safety of high-level waste. Over the past decades, we have achieved scientific and technical progress, but there is still the critical point. The critical point is that how much convincing we are. So with respect to uncertainty of safety for a period beyond the human history timescale. Yeah. So we need very sound data predicting radionuclide migration and retention mechanisms in engineered barrier and the geologic barrier, repository. So in addition, we should learn from the nature, and there are natural analogs, which are the occurrences of materials and processes so analogous to expected materials or processes in a radioactive waste repository. So natural analogs are very, very helpful and used to clarify the ability of the geologic environment and engineered system to contain the waste. And it can also provide a variety of technical and long-term stability information of the overlying geologies of the repositories. And thus, natural analogs can be also used as supplementary safety indicators and the effective communication tool with the public. So because they exist close to our living surrounding environment. So more critical, the point to emphasize is the public acceptance. So as you said, nuclear technology is not only a technical issue, but also social political issue. So without trust of the people, so we can't take a step forward. So this is a very critical part, in particular the site selection of a repository. So in my opinion, so it is imperative that we constantly strive to deliver technical progresses, evidences, and arguments in view of the public. This is one of the important aspects to implement the long-term geological repository, for example.
This is sort of a side question, but obviously, what do you think? In Korea, there's been a long history of public engagement in citing radioactive waste facilities, spent fuel, high-level waste, low-level waste. What do you think? And obviously, there are many other countries that are doing similar programs right now. What do you think the major lessons learned from Korea are for maybe some of these other countries that are, either in the middle of establishing a repository program or just maybe starting on a program soon or in the future?
Yes. So we have conducted the long-term safety research for radioactive waste disposal since 1997.
1997.
And so we learned a lot. And so we have performed the basic research with respect to the nuclear waste disposal in a laboratory level. And now we want to expand from laboratory to field. And in a underground rock laboratory, for example, this is indispensable for acquiring license to construct a nuclear waste repository. So now, we are planning to construct the underground rock laboratory, where we want to verify and validate the data we achieved in the laboratories. And this is so-called the important step to the construction of a final repository. So I think my government will invest the much money for installing such kind of big laboratory project. And this is hopefully will be done within near future. But as we said, site selection is one of the obstacles to implement this kind of force.
Have you had any international participation in some of these research activities that you've had with regards to underground, experiments and research?
So I have collaborated with Japanese colleagues.
Okay.
So especially at Kyoto University and Tohoku universities, and I have contracted one MOU so with KIT, the Karlsruhe Institute of Technology, so in Germany, and so we are common interest so regarding the research activities in deep geological repositories, and so we exchange the personnel and we exchange the information what we obtained in the laboratories. So I hope this continued the collaboration between both institutions are very helpful to advance, for example, for the securing the safety of nuclear waste repository.
A related issue to site selection for radioactive waste, spent fuel. Korea is about to begin decommissioning its civil nuclear fleet. It's obviously had a very successful civil nuclear program that it's developed over the decades, and its first ever commercial unit, Kori 1's already been shut down. Wilsung 1 will likely stop operations shortly within the next few years. One of the major costs of decommissioning is, as you know, managing and safely disposing the radioactive waste streams that arise from the process. And in some sense, it's a bigger problem if you try to accelerate the decommissioning process, because you don't allow some of these radionuclides to decay. What are your thoughts on how to manage this challenge in Korea at the moment?
The people in Korea believe that the decommissioning industry is a good business model, but a number of techniques for decommissioning have to be developed. As you know, there are three main methods for decommissioning, and so we have a specific situation in the Republic of Korea. So regarding spent fuel storage, for example, and due to a lack of a spent fuel storage facility at the Kori site in Korea, so a deferred dismantling of Kori 1 is recommended, so in my opinion. And on the other hand, so many engineers in Korea think that the shutdown reactor Kori 1 is a good experimental object for research. So we will gain scientific and technical insights in more details in structural material integrity, so in the nuclear power plant, and the outcomes will be applied for designing a more safer and reliable nuclear reactor in the future. So in this regard, there is no need to rush to decommission, so in my opinion, and we should have time to think about how we will proceed the decommission in the future. This is, I think, important aspect. So with respect to decommissioning, so in the Republic of Korea.
A basic question: what would be the destination of decommissioning waste in Korea? Would that be the Gyeongju low intermediate level waste repository?
Yes. So as you know that we have one low and intermediate level radioactive repository in Gyeongju, and Gyeongju has a capacity of 800,000 drums. So one drum has a volume of 200 liter, and so in 2015, the Gyeongju repository has been operated, and mostly decommissioned waste will be transported to Gyeongju repository site. And so now we have so we are in the second phase of Gyeongju repository. So we are planning to submit the permission, the license, so to the Nuclear Safety and Security Commission for constructing the second phase of low and intermediate level waste repository. So the first repository is constructed in a relatively low, underground, the silo concept. And in the second phase, we are planning to construct the near surface repository. So with a capacity of, when I remember rightly, around 125,000 drums. And so the most of the decommissioned waste will be stored in Gyeongju site.
My understanding of the Gyeongju facility is that it likely would need to be expanded in order to accommodate future waste and obviously decommissioning waste if that arises. And obviously there's been fairly high costs associated with that facility, given all the engineered barriers and the payments that you have to make to the municipality. So. Can you give us maybe any thoughts or insights as to how much all of this might actually cost?
So that's why we are planning to construct in the second phase of the repository project, the near surface repository, because the silo type repository is too expensive.
Yeah.
And one drum costs around 12,000 US dollars.
Okay.
This is tens of times expensive than the disposal cost in other countries.
Yeah.
And so that's why we want to construct the near surface repository with the same safety level.
Yeah.
So with the lower the cost.
Yep. Yeah. The silos in the low intermediate level waste facility, the engineered barriers. I heard that the containment or the concrete is thicker than a reactor containment dome, right?
This is massive.
Yeah.
It's a massive concrete facility.
Yeah. You participated in our trilateral nuclear energy dialogue. We've hosted experts from South Korea, Japan, and the United States, and the purpose of the dialogue is really to talk about issues related to nuclear power, spent fuel management, decommissioning, how to manage radioactive waste, R&D, innovation. What do you think are some of the areas for international cooperation amongst these three countries? They share obviously many of the same problems, including radioactive waste, spent fuel management.
So I have a fortune to participate in the Gavi's trilateral dialogue between Korea, U.S. and Japan. This is the first time for me to participate in this dialogue. I learned a lot from this forum, for example. And I think the U.S. companies such as Energy Solutions and the Holtec have plenty of practical experiences on the storage of spent fuel and the decommissioning. Such practical experiences in the United States will be a big help to the Korean decommissioning industry, which just starts. And the collaboration between U.S. and ROK will move toward the direction that helps each other if the collaboration agenda is well chosen and set according to the policy of each country. But this is really helpful to collaborate in the area of decommissioning and spent fuel storage between U.S. and ROK.
Kind of related to these remarks and maybe sort of an opposite question to a question that I posed earlier about what are the lessons learned about spent fuel management from Korea. Obviously there have been very few countries that have actually achieved considerable success or progress in spent fuel management. Is there a country or countries that you consider maybe an ideal model for Korea to follow as it progresses in its own spent fuel and radioactive waste management programs?
Yes. So in my opinion, in the field of spent fuel storage and decommissioning of nuclear power plants, the U.S. is definitely an attractive partner for Korea. So as mentioned before, the U.S. companies have gathered lots of practical experiences on spent fuel storage and decommissioning. So related to the final disposal of spent fuel, the European countries such as Sweden, Finland, and France are advancing and made great efforts to have a good relation with the public by gaining the public trust on the waste management policy of their government. So we need strategic multilateral collaboration depending on the field, for example. And so as mentioned, we will have close collaboration in the fields of decommissioning and spent fuel storage, together with the U.S. And so I think the collaboration with those advanced countries in the management of spent fuel is highly necessary. So for the development of waste management in the Republic of Korea, I think.
Maybe just a final sort of a side question again. What do you? There's been many, throughout history. There's been many proposals for multinational spent fuel repositories.
Yes.
For example, I think the most recent example is Australia, where you have a more of a local government that was expressed some interest in perhaps hosting or becoming the final destination for foreign international spent nuclear fuel. What do you see any hope for this type of scheme, or do you think that this is a rather maybe an unrealistic? So I guess what I'm trying to say is, do you see any possibility of South Korean spent nuclear fuel maybe going to another country and perhaps alleviating this issue altogether?
I think this is one of the options, but international, related to the international problems, and so we have always discussed centralized radioactive waste repository, but so there are so many obstacles to overcome, and I think the IAEA does not allow, for example, to have a centralized radioactive waste repository in one country, but this is
I guess the official position is that every country has to manage their own spent fuel.
This is my personal opinion, because transportation and some difficulties in implementing this kind of grand projects in the world, and so we have a lot of things to be resolved. But so at the moment, in my opinion, we have managed the radioactive waste generated from the countries by themselves. This is my personal opinion.
Dr. Yun, thank you so much again for taking the time to speak with me and your insights on some of these many challenging and difficult issues. And thank you again so much for participating.
It was my pleasure, and thank you so much for the invitation.
Okay.
Thank you very much.
All right, thank you, Dr. Yun.